Well, today let us see the process of garbage collection in Java. Now let us first see the process of storing objects in Java. Now we have a stack location and we have a heap memory location. So now when we create an object for a class say A, we write A1 is equal to, or I'll just start off with a simple A. I just write A1. Now as soon as you write A1, you create a reference on the stack that currently does not point to any data on the heap. Now, as soon as I do A1 is equal to new A, we are creating some data on the heap. So this is the heap. We create some data on the heap that is related to the object, and we associate this reference with this data stored on the heap. So similarly, I can even directly create an object say A2, and another reference comes on the stack called A2, and it points to some object on the heap. So how do we really reach to an object is when we say a1 dot x is equal to 40, and this x is some value which is associated with the object A, class A, and it is stored at the memory location in the heap. So now in order to make this calculation or this value a1 dot x, the system approaches the reference, and through the reference it gets to the memory address where the value of x is stored for the object a1, and it modifies x here and changes this to 40. So in case we do not have any reference to this object, we have no way to reach to this object to modify this value. So how do we remove the association between this object and the reference? There are two ways I can do it. I can say very simply a1 is equal to null. So by just simply writing a1 equal to null means this a1 now refers to no data on the heap. And the second is that I can assign this a1 to some other object like this. So now a1 refers not to this data but to the data to which a2 is referring to. So we have two references to this same data or object, whereas this object that earlier was referred by a1 is now not referred by any reference and can now be removed by the garbage collector. So garbage collector is a process that runs in the background and constantly checks for objects that do not have any reference on the stack, and therefore they have no approach so as to access their data. So any object that is on the heap but has no reference on the stack is a candidate for garbage collector. So this is a process that continuously goes on in the background, and for an object the memory is allocated by the new operator, and the garbage collector it removes the memory that is allocated by the new operator. So any memory which is allocated beyond the new operator has to be removed by using some other method. It cannot be removed by the garbage collector. So I hope this clears the concept of garbage collection. So we had designed this system of a reference on the stack and object on the heap just to make this garbage collector a feature in Java. Otherwise in C++ all objects they are on the stack. Now we'll just try to make a program to see what option we have for garbage collection. So I'll just create a new class, call it GC garbage collection. Now what really happens is, as soon as the system removes some object from the heap, it provides a last chance to the programmer through a method which is called finalize to remove any resources that you require to remove from the object before it is removed from the memory. So this is the last resort or chance for the programmer to really deal with the object before it is removed from the memory. So we'll just try to make a program where we'll create a number of objects so that the garbage collector thread runs and removes the objects from the memory. So we'll create a count. I'll create a counter, or I'll say created. So this will keep a track of the number of objects that have been created, and this I'll take a counter that gives a count of the number of objects that have been destroyed by the garbage collector. Now I'll create a method called show where I put down a loop, say int I is equal to 0, I less than 30,000, and create a number of objects that are all without a reference. So all these objects are very ready candidates for garbage collection because they do not have any reference associated with them, and we have created a substantially large number so that the memory really becomes short and garbage collector thread runs and we are able to see the output. So I'll try to add some variables to this class so that the object really has some weight. Double value, let us see. So now for every object that we create, we'll increment the value. So I'll write down the constructor and print any statement in this so that we can keep a track of how many objects are in picture right now. Created object and increment this value. So this will give us an indication of how many objects are currently being created, and now we'll write down the method to see how many objects have currently been removed. For that we need the method finalize that will just add using source implement method. This is the finalize. Now this object class I'll not discuss it right now because this will come down when we'll discuss inheritance. So this is the place where we can write down the code to free down any resources that are associated with the object that is going to be removed. So I'll just put on a print statement to just keep a track of the number of objects removed. So I'll also make this method static so that I do not have to create an object of class GC. I have some error here. Oh, just semicolon in the wrong place. So I've put down the method finalize in position. I have the constructor in position. I have two variables to keep a track of the number of objects created, number of objects that have been destroyed. I have a method creating a number of objects, and I just need to call this method to complete the thing. So I'll just now run this program. I hope this is clear to everybody. We have a class GC, we have a method to create a number of objects that are without reference, and in the main I give a call to this method. So I'll just run this program. So I'll just see. You see, it is created a number of objects, but the important thing is the counter hasn't moved beyond 0. So I'll just explain to you why this has happened. But let us see whether it has really removed any object. Well, there are. It has removed certain objects, but the counter of the objects has also not moved beyond 0. Now the reason behind this is the variables that we have created, they are both instance variables. So they are created for every object. They start from 0, become 1, but because next time another object comes into picture, for which again created starts from 0, destroyed starts from 0, so the values have never moved beyond 0. So I'll just make them static in order to get their values shared between all the objects, and we really see the effect. So I'll just again run this. Oh, yes. Right. So I'll just run this program again. Just we can see it has removed this many objects and it has created that we had put down in the loop around 29,999 I suppose. Yeah. So we'll just see where the last object has been created. Way beyond. So it has removed a number of objects and there we have it has created 29. So we can see the objects have been created, the objects have been removed according to the memory position. So this is how garbage collection works. This is the method you need to override to put down the code to free any resources from the object, or we can say this is the method that is called before any object is freed from the heap. So I hope this clears garbage collection.